Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. I give you here links to online seminars and study manuals I wrote for exams P, FM, IFM, and LTAM. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's problem number 2 from the first exam LTAM that was offered in October 2018, not so long ago. This is a multiple choice section, problem number 2. You are given that the force of mortality at age x is equal to 0.06 when x is between 30 and 40, and it's 0.03 when x is between 40 and 60. Calculate, deferred by 5 years, probability of dying within 16 years for somebody who is now 30 years old. And here's the solution. So this probability is the same as probability of, for this 30-year-old, of surviving 5 years, and then, once this person becomes 35-year-old, dying within 16 years. And then we note that the force of mortality is different at different periods of time. In fact, between ages 30 and 40 is different than later. So we split that period of time of 16 years after 35 into the part that is with one value of force of mortality. The next 5 years are the same as between 30 and 35, and then ages after 40. So we write this 16Q35 as 5Q35, which is the probability of dying during the next 5 years for the 35-year-old, plus 5P35, which is the probability of surviving, times the probability of dying within the next 11 years once this person becomes 40-year-old. Now, of course, these two possibilities of dying between ages 35 and 40, and then dying between ages 40 and 51 are mutually exclusive. So we just add these two probabilities, and of course we get that probability, the sum of the two, is equal to 16Q35. And now every single of these probabilities of survival or dying that we wrote out is within the context of constant force. So we know what they are. Probability of survival under constant force of 6% for the ages between 30 and 35 is e to the minus number of years, so 5, times the constant force, which is 0.06. In general, it's e to the minus mu, the constant force, times n, the number of years, or x, the number of years, or whatever the notation for it is. But it's number of years times the constant force for the probability of survival, because the probability of survival under constant force of 1 year is e to the minus mu. And then probability of dying is 1 minus e to the minus mu, and so on. So probability of dying for the 35-year-old, dying between ages 35 and 40, is 1 minus e to the minus 5. And that's 5 years between 35 and 40, times 0.06, the constant force between ages 35 and 40. So that's the first term. And the second term, well, the probability of surviving 5 years from ages 35 to 40 is e to the minus 5 times 0.06. And now, for the probability of dying between ages 40 and 51, the force of mortality is now 0.03. And the probability of dying is 1 minus e to the minus 11, the number of years, times 0.03, the constant force. That's it. It simplifies a little bit because e to the minus 5 times 0.06 is e to the minus 0.3, and we write out all the other numbers. And we can see that e to the minus 0.3 cancels out, so this becomes, if we multiply it out, e to the minus 0.3 minus e to the minus 0.93. We calculate this, and this is approximately 0.34626451, or approximately 0.35. Answer B. Please remember, this is copyrighted material. The problem itself comes from Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.